Okay, buddy. So we're going to do weathering, Chapter 9, weathering and mass movement. There's a couple animations in the weekly module that you're going to need to look after, and one video, actually two videos on the lock and cheetah disaster from a few years ago. So make sure you watch those and be familiar with the terms and everything that the animations use, because those are going to show up on your test. Okay, so let's go over here and we'll go to the lecture. Not a lot there's not a whole lot in the master assignments on this, but make sure you know finish them promptly and everything. Okay, so when we talk about weathering and mass movement, what we're talking about are the denudation of the landscape. And this is the process where the landscape is worn away or rearranged. And there's three ways to do this. Weathering, where you break down the rock on the surface or just below the surface, and mass movement, where the surface is transported from one point to another, or erosion, which is the transport of materials by wind, water, ice, waves, and gravity. And we'll be talking about water, especially next week when we look at rivers. And also be familiar with this, geomorphology. It's a subfield of geography where you investigate the origin, evolution, and distribution of surface landforms. We teach it down there at Northridge. It's a more advanced course, but you should be familiar with the term. So in terms of weathering and mass movement, a lot of this has to do with with slopes, and slopes are either stable or they're unstable. Now remember, slopes are inclined. Okay, if you can kind of see my hand there, they're inclined, and they're under the effect of the structure of the rock, the climate, the angle of the incline, and over time, the weathering loosens the material. We'll go over weathering here in a second. The slope angle might change. There's raindrops, freezing, thawing, moving animals, wind. All these promote erosion. And eventually, the rock particles, the sediments, will either overcome the forces of gravity and the adhesion, uh, where they're pulled down to the surface, and they will move. So they're stable. The slope is stable if the strength exceeds gravity and denudation, the ability of the slope to be denudated. It's unstable if the strength does not exceed either one of those. And here's an example of a unstable slope. And you can see all this used to be up here, and looks apparently from moisture. The moisture looses the adhesion, the force of gravity takes over, and this all is a mass movement. This all falls down, moves down the slope. And here it is this is from your book, figure 9.1. So here's what's working on it. So here's the particle, and the slope is all filled with particles. And there's a cohesion there between the particle and the surface. There's frictional resistance, okay? And there's gravity. So all these things are acting upon the various particles that make up the slope. And when something happens to change any of these, that can change the ability of the slope to be stable. And it would, of course, become unstable. And they fall down, oftentimes through physical or chemical weathering. They are transported down the slope and deposited. And the fine materials go the furthest. The coarser materials, because they're heavier, fall out earlier. So on these debris slopes, you're going to have the heavy materials here and the finer materials further down. And it'll be the same thing for rivers and river deltas when we speak about this next week. Okay, so here's an example of another one, like a sand dune, for example. So there's sand, which is basically these angular pebbles. If it's fine, angle of repose, the ability of it to stay stable, might be 35 degrees. If it's angular, and so the parts fit together really tightly, that angle might be 45 degrees. Here in the Arabian Desert, here's a slope, and it's 25 degrees. If any of these change, this goes up to 36, unstable, falls down. This goes up to 46, unstable, falls down. This goes up to 26, for example, falls down, and that's your mass movement. Okay, so we'll stop here, and then I'll get to weathering on the next chapter, or the next part, okay?